Well, today we're going to dig into a super detailed climate report for Salalah, Oman to see if some cutting-edge agriculture can actually make that happen.
Now, this whole deep dive is based on a really specialized report. It was put together by the ETUC Climate Studies Unit, specifically for the ag tech brand bluepeat. So what we're really looking at here is where hard climate science smashes right into high-tech farming. It's a fascinating intersection.
So, this really boils down to one big question. Can these really picky, high-value crops, we're talking blueberries, maybe even ginger, can they actually survive, let alone thrive, in a place like Salalah? We're looking at the potential of advanced hydroponic systems. The data is what's going to give us the real answer.
So we're zeroing in on Salalah province in the Dhofar Governorate of Oman. And what's really important here is the data we're working with. That gives us a really strong foundation for everything we're about to talk about.
Okay, these two numbers right here, they tell us a huge part of the story right away. The USDA hardiness zone is 13A. What does that mean? Basically, it never ever freezes. Zero risk of frost. But then you look at the AHS heat zone, zone 8, and that is a huge red flag for heat. We're talking somewhere between 90 and 120 days every single year where the temperature climbs above 30 degrees Celsius. And well, this chart tells the whole story for Salalah. Each bar is the number of chill units for a given week. And you can see they're not just at zero, they're consistently in the negative. What that means is that it's so warm that instead of accumulating chill, the heat is actively canceling out any potential for it.
The total annual chill units are less than 100. It tells us without a doubt that growing traditional temperate fruits out in the open here is just, it's not going to happen.
This table gives us a fantastic bird's eye view. First, look at the annual growing degree days, or GDD. It's over 6,000. That's a huge number, and it basically means there's a ton of available heat for plants to grow, suggesting a super long, potentially productive season. But, and this is a big but, look at the annual ET0. That's evapotranspiration, or how much water is basically being sucked out of the plants and the soil by the atmosphere. At over 1,600 millimeters, that is screaming high water demand.
And this chart just hammers that point home. This isn't something that just happens in the summer. That water demand, the ET0, it's high all year long. Yeah, it peaks in May, but look, it never really gets a break. The takeaway here is non-negotiable. Any project here needs a seriously robust and reliable irrigation system from the absolute get-go.
Now, let's talk about the next major factor, and it's a big one: humidity. As you can see, it climbs and climbs through the summer and then just gets extreme from August to November. I mean, look at that peak in October, over 91% relative humidity. For anyone who's ever grown anything, you know that a number that high is a giant flashing red light for problems like fungal diseases and mold.
And this next chart shows you exactly what happens because of that humidity. The vapor pressure deficit, or VPD, it just tanks. The easiest way to think about VPD is as the thirst of the air. When the air is really humid, it's not thirsty, so the VPD is low. And when that happens, the plant can't really transpire properly. It's like it can't breathe out. This puts a ton of stress on the plant and, you guessed it, creates the perfect, humid, stagnant environment for diseases to thrive. This makes controlling the environment absolutely critical.
Just a quick glance at this table tells you a lot. Just focus on that precipitation column for a second. In 2018, they got a whopping 742 millimeters of rain. A few years later, it was less than 200. That is not just variation, that is wild fluctuation. This is not what you'd call a stable pattern. And these two charts side by side make it crystal clear. On the left, you've got temperature. Yeah, it's got a slight warming trend, but it's pretty steady, pretty predictable. But then look at the chart on the right for precipitation. It's all over the place. It's completely erratic. The bottom line here couldn't be simpler. You absolutely cannot create a farming plan here that depends on rain. It is just way too volatile.
So let's just quickly list out the biggest hurdles we've uncovered. First, a total and complete lack of chill units. Second, that extreme seasonal humidity, which leads to our third problem, persistently low VPD. Fourth, a very high, year-round demand for water. And fifth, that incredibly volatile and unpredictable rainfall. These aren't opinions. These are the non-negotiable environmental facts on the ground.
But here's the thing. For every single one of those challenges, there's a strategic answer. You have to select crop varieties that are no-chill or low-chill. There's no way around it. A powerful independent irrigation system is a must-have. And finally, you'll need to be monitoring VPD in real time to keep your plants healthy.
So let's go back to our original question. Is it possible? Yes, it is. Is it going to be easy? No way. Not at all. Success in a climate like this demands the absolute right technology paired with the right expertise. If you're looking for a detailed consultation on how to actually build a system that can beat these odds, the contact info for the team at bluepeat is right there for you.